Hello friends, welcome to my channel. My name is Emily and here on my channel I make crystal and geology related videos. So if that sounds interesting to you, be sure to subscribe because I put out new videos every week. And yes, I'm doing every week again. Nothing is going to stop me, I promise you. Hold me accountable. You're going to see a new video every single week. I'm spending my days off now. Every day off is being spent making a video. I promise. And if I am lying to you right now and I don't put out another video in a week, you can unsubscribe to me. I give you permission. Today's another video in my new series, which is crystals in your state, where we go through a specific state or region and talk about the interesting minerals, the geologic history, and some cool places in that state. So today I'm doing one of your suggestions, which is for the state of Montana. I'm really excited to talk about Montana because I've never been there, so it was really interesting looking into its geology and history. So I hope Montana, you're out there watching this, and I hope you enjoy the video. Let's get right into the interesting minerals and resources that can be found in the state of Montana. After the minerals, we'll talk about the geologic history, and then we'll talk about some interesting locations. And also, before we get into the minerals of Montana specifically, I just want to mention some of the minerals that are the most common on Earth's crust that you'll find just about anywhere. The most common minerals on the crust are quartz, feldspars, pyroxene, amphibole, mica. Although it does not make the list of top minerals on the crust, calcite is very, very common. You'll probably see it just about anywhere. Resources found in the state of Montana include gold, silver, copper, iron, zinc, lead, kyanite, talc, graphite, limestone, silica, clay, oil, natural gas, fluorspar, sand and gravel, and coal. Alder Gulch in Montana is actually the site of the world's largest gold placer gold strike in world history, producing $10 million worth of gold in the first year. Montana's official state gemstones are agate and sapphires. So Montana is known for its really beautiful and unique agate. Some of these pieces have incredible banding, and there's also a type of Montana moss agate that can be found in the state, although it doesn't really look like your typical moss agate. It kind of looks more like a dendritic agate or a chalcedony, but anyway, it's called Montana moss agate. This unique agate forms in the Yellowstone River in the Yellowstone Park region, which is in Montana. Montana is actually right on the border of Wyoming, which is where Yellowstone is. Yellowstone Park kind of crosses into Montana a little bit. This agate owes its unique banding and inclusions to volcanic activity in the area's past. And Montana is known for its sapphires. Sapphires can be found all across the state. Many high-quality sapphires are found in the Yogo Gulch, which is located in the Little Belt Mountains. These are known as Yogo sapphires, and they are a beautiful cornflower blue and are known for their transparency. Sapphires are also common in other areas of the state, and they do come in different colors. Yogo sapphires are really abundant in this area, and they are some of the highest quality and most valuable sapphires in the world. Many types of garnet can be found in Montana. Almandine, pyrope, grossular. Fluorite can be found here. There are some beautiful specimens of fluorite and fluorite with rhodochrosite, which I've never seen this combination before. They are so beautiful. I would love a piece like this. I love the pink and purple. And of course that means Montana also has rhodochrosite, which I didn't know, and there are some beautiful pieces that come out of the state. Montana also has some beautiful pyrite and chalcopyrite. There is also marcasite, which is a polymorph of pyrite. Polymorphs are two minerals that have the same chemical composition but different crystal structures, therefore they're different minerals. Beryl can be found in Montana, including aquamarine and emerald varieties of the mineral. Like I mentioned, calcite is an extremely common mineral that's found just about everywhere, but some of the calcite I saw from Montana was really cool and unique. It is known for some really high translucency, very unique crystal structures such as stalactites or scalenohedrons. Scalenohedrons are just those dog tooth shapes. I just love the name. Since there's an abundance of copper in the state, you can find copper minerals such as malachite, chrysocolla, azurite, cuprite. I saw this one really interesting piece that was a copper pseudomorph of azurite, and a pseudomorph means false form, which refers to a mineral that has the structure of a different mineral, usually because the original mineral has been replaced by something new. In this case, the azurite was replaced by copper, but the shape is still that of azurite. I think these pseudomorphs create some really cool looking crystals. Torbernite is one of the minerals I talked about in my spooky and dangerous minerals video because it is radioactive and it contains uranium, and this seems to be found in small amounts in Montana. Gypsum can be found here, including satin spar and selenite varieties. Different varieties of quartz can be found here, such as clear quartz, smoky quartz, amethyst, and citrine. Other minerals include aragonite, cerussite, hemimorphite, apatite, wolfenite, vesuvianite, black tourmaline, spinel, barite, rhodonite, rutile, and many, many more. The full list that I got this from on Mindat will be linked down below if you'd like to see the full list. Also, I forgot to mention, all the photos I'm using are photos specifically from Montana, not just general photos, so all these specimens have been found in the state. And when I was looking through the mineral list in Montana, I feel like I saw a high amount of names that I didn't recognize. I've never seen them before, so I just wanted to share some of those interesting ones. First up, plumbogerosite. I just loved that name. I don't know why that sounds familiar. Maybe I heard it before because it sounds ridiculous, but it's actually really interesting looking. All of these are really interesting looking. The next two I'm not even going to try to pronounce. I'm going to get it wrong anyway, but they both have really cool looking crystals. And last, I saw pseudomalachite, which I did not even know existed. While it looks just like malachite and also contains copper, pseudomalachite is a phosphate mineral and malachite is a carbonate mineral, so they are really not the same, except for the fact that they have copper in them. Pseudomalachite and real malachite can form together with other copper minerals, and they do look really, really similar. Now let's get into the geology and geologic history. Let's start with the geologic provinces. There are only 2 geologic provinces in the state of Montana, and geologic provinces are regions that have distinct geologic features, and they span across multiple states. There are 2 cats in front of me right now being ridiculous, so if you hear crinkling, the first province in Montana is the Rocky Mountain Province. The Rocky Mountain Province obviously includes the Rocky Mountains. The Northern Rocky Mountain Province specifically is the area that covers Montana, and it is known for its smaller mountain ranges as opposed to the Central and Southern Rocky Mountains. And the next province is the Great Plains. The Great Plains falls to the east of the Rocky Mountain Province and is characterized by high plains, small mountains, and glacial deposits. The geologic history of Montana begins with the Wyoming Craton from the Archean time, which was 3.8 to 2.5 billion years ago. A craton is a large, stable piece of continental crust that has survived a long period of geologic time and makes up the base of a continent. This craton of old rock was added to the continent of Laurentia about 1.86 billion years ago. Laurentia is what is now known as current-day North America. On this map, you can see that Laurentia is turned on its side and it sits on the equator, which is a very different orientation than current-day North America. This is not the only craton that makes up Montana, but it is the oldest, and this map shows the other cratons that make up the region. Evidence of collisions between Laurentia and other land masses can be seen from deformed metamorphic rocks from 2 billion years ago in the Little Belt Arc. Around 1.6 billion years ago, an ancient sea called the Belt Sea covered the area and deposited over 18,000 feet of sediment from nearby highlands. Between 1.6 billion years and 540 million years ago, the supercontinent of Rodinia formed, and then it broke up again later. Montana and its nearby states don't show much of this tectonic activity because they were more inland and not quite along the coast, and there was little activity affecting this area at the time. While much of Montana is created by deposition of sediments that created sedimentary rocks from various different seas and erosion of mountains over time, there are also igneous rocks from lava flows on the sea floor around 700 million years ago. In the Cambrian to the Devonian period, around 540 to 350 million years ago, the states that are currently making up the west coast of the United States were not attached to the continent yet, and the edge of the coast was near Idaho-Nevada border. This was a peaceful, passive margin that then turned into an active subduction zone where the oceanic plate was moving underneath the continental plate. This created volcanoes, folded rocks, and new rock and sediment being added to the continent. Over millions of years, this subduction zone added many new terrains to the continent and caused multiple mountain building events. A mountain range known as the ancestral Rocky Mountains existed around 300 million years ago, and the erosion of these mountains Mountains caused sediment to be deposited in nearby seas, again, which eventually created more sedimentary rocks in the area. During the Triassic and Jurassic periods, sea levels were rising and allowed for a continental sea to form across much of the western U.S. Mudstones and sandstones were deposited in low-lying areas in river channels throughout the Rocky Mountains, and these rocks that were deposited are known today as the Morrison Formation. The Morrison Formation is one of the best sources of dinosaur fossils in the entire country. While the formation is huge, it is only visible at the surface and accessible in a few locations. During the Cretaceous period, around 120 to 66 million years ago, much of the western U.S. was covered by a shallow sea called the Western Interior Seaway. During this time, almost the entirety of Montana was covered by water. This sea was created by the Farallon Plate, which no longer exists, moving under the North American continental plate at a very shallow angle, which caused the land to warp downwards, which then allowed water to accumulate. This sea allowed for the deposition of sediments and creation of sedimentary rocks. The sea eventually closed due to regional uplift, and obviously there's no sea there today. The Rocky Mountains began to form from the Sevier orogeny about 100 to 72 million years ago. This mountain building event began by, again, the Farallon Plate subducting under the North American plate. The next phase of creation for the Rocky Mountains was the Laramide orogeny around 65 million years ago. This oceanic plate continued to move under the continental plate, but the angle became shallower, which allowed for mountain building to occur farther inland than it would normally on a subduction zone. Eastern Montana lowlands were covered in up to 4,000 feet of sediment from erosion of these newly created mountains. During the Laramide orogeny, the collision of plates created the Lewis Overthrust Fault, which pushed older rocks on top of younger ones. This is something that can be seen in Glacier National Park. The Rocky Mountain Front is the area where the Rocky Mountains meet the Great Plains. In Montana, along the Rocky Mountain Front, you can see evidence of this thrust faulting in the area from these ridges where rock is exposed at a crazy angle. At the end of the Cretaceous period, around 65 million years ago, there was a mass extinction where around 50 to 70% of all species on Earth went extinct very suddenly. Because of erosion and just lack of sedimentation, this boundary isn't recorded in the rock record in many places. However, Montana does have some exposed areas of this boundary in the rock record, and it is used for research. Today, Montana has over 100 named mountain ranges from these repeated mountain building events, which are a part of the Rocky Mountains. The Beartooth Mountain Range contains the highest peak in the state, which is Granite Peak, at 12,807 feet high. 2.6 million years ago, continental ice sheets began forming over Canada and moving downwards to cover the northern US. There's a lot of evidence of this glacial activity still in Montana today, especially in Glacier National Park. While Montana doesn't have any active volcanoes today, it does have a very extensive history of volcanic activity, mostly caused by the tectonic activity to the west, which was that subduction zone. Evidence of this volcanic activity includes igneous intrusions, pillow basalts, sills, dikes, batholiths. Shonkinite is an igneous rock that can be found in this area that is low in silica and contains minerals such as augite, olivine, feldspar. This is significant because this is a very rare rock and it is found in very few places across the world, but it is in abundance in Montana. Montana is also extremely close to the Yellowstone supervolcano, which is a hotspot under Wyoming, which again is right along the Wyoming-Montana border. It is still expected to erupt again, but the last known eruptions were 600,000 years ago, 1.3 million years ago, and 2.1 million years ago. While not a caldera-forming supervolcano eruption, there were also lava flows around 70,000 years ago. This Yellowstone supervolcano is a hotspot, just like Hawaii, and it stays in one spot as the continents move around it, which means during these previous eruptions, the hotspot was in a slightly different place in the continent than it is today. Square Butte in Montana is an example of a laccolith, which is an intrusion of magma under the surface that moves upwards through weaker layers of rock and creates uplift in the region. These igneous rocks are visible on the surface today because the sedimentary rock that they intruded into eroded away, leaving behind the stronger igneous rock. There are also other buttes nearby that formed from the same igneous activity. The Adel Mountains volcanic field shows igneous rocks from volcanic activity back during the Cretaceous period. Because of erosion, all the volcanoes that used to exist here have eroded away, so there's no cones left, but there are still many volcanic features in the area. This lava flow formation is estimated to be around 75 million years old and created during the overlap period of the thrust faulting and volcanism. The Timber Hill basalts is another significant igneous feature that now creates a mesa in Montana. It was created from an ancient lava flow around 6 million years ago. The abundance of igneous intrusions in Montana and the surrounding states created many valuable minerals and resources. The boulder batholith is a pluton of igneous rock from the early Laramide orogeny, and this is in Butte, Montana, which is a big mining town because of all these valuable resources. This area was a major producer of copper from around 1880 to 2004, unearthing about 21 billion pounds of copper, as well as other resources like zinc, lead, manganese, silver, gold, and molybdenum. Igneous complexes like these often have high amounts and highly concentrated valuable minerals. There are many other igneous intrusions just like this across the state and area that also contain resources. The Lemmy Pass area of Idaho and Montana is also a large source of rare earth elements, including thorium. This area formed during the Sevier and Laramide orogenies. Mountain building events with lots of metamorphism and igneous activity allow for many minerals to form. So basically, to recap the geologic history, Montana is mostly covered in sedimentary rocks from multiple seas covering the area throughout time, as well as erosion from nearby mountains. The Rocky Mountains cover the western part of the state, while the Great Plains are in the east. Evidence of faulting can be seen across the state where older rock has been pushed on top of younger rock, as well as rock folding. The state has an extensive history of volcanism, with lava flows covering large parts of the land and other igneous features that intrude into the sedimentary rock. Because of multiple mountain building events and tectonic activity, there are also many metamorphic rocks that have been altered through heat and pressure. In more recent times, glaciers have covered the landscape and carved out valleys, lakes, and other features in this rock. Now let's talk about some of the geologically interesting places in Montana. Like I said, I've never been to Montana, so it was hard to compile a list of the cool places here. Much harder than it was to make a list for Arizona because I've been there a million times and I've seen most of the cool places, so I could list many. So if there's anything really cool in Montana that I missed, please comment it down below. Montana has 55 state parks as well as 1 national park and many mines. There seems to be no shortage of cool places to visit here. So let's start with the mines. Like I mentioned, Butte, Montana is a big mining town. The Butte Mining District is where many of the mineral photos I showed you earlier were from. The Butte Mining District began with sulfide minerals, silver and copper, and it is now producing copper molybdenum. That word's gonna get me every time. Copper minerals such as malachite, azurite, chalcanthite, chrysocolla, cuprite are also mined here, as well as non-copper minerals like fluorite, rhodochrosite, amethyst, smoky quartz, topaz, and much more. Next, we have the Black Pine Mining District. This used to be a gold and silver mining area, but it now seems to be a ghost town, and it seems like you can visit it. I also forgot to mention, before you visit any locations to go and collect rocks of your own, make sure you have any proper permissions to collect rocks or visit these locations. Some old mines or monuments are on private property. Don't go into anywhere you're not supposed to. You can't collect rocks from national parks. Just make sure you're not out there on land you're not supposed to be on, taking things you're not supposed to take. Next, we have the Montana Blue Jewel Mine. This mine is in Helena and it is open to the public for sapphire mining, but it requires reservations and it seems really serious. Like you really got to get out there in the elements and vigorously mine yourself. So it's not just a fun little thing where you buy that bag and sift through it. Like you're really out there mining, so you got to be serious if you go to this one. Next, we have the Yogo Gulch region, which like I mentioned earlier, is abundant in sapphires. I'm pretty sure you can go there and visit. The Ruby River Reservoir, oh my God, what a tongue twister. The Ruby River Reservoir near Virginia City and Alder is an area where you can hunt for your own garnets and gold. Crystal Park is an area in southwest Montana where you can visit and hunt for your own amethyst and smoky quartz crystals. Now, of course, Glacier National Park. Looks so beautiful. I would love to visit it. Many of the rocks in Glacier National Park were sedimentary rocks that were deposited in this belt sea over 1 billion years ago. The rocks in Glacier come in various beautiful colors, lots of reds and greens, and this is caused by iron. Stromatolites can be seen in the park, which are ancient algae fossils from the belt sea. Stromatolites are interesting because they show some of the earliest life forms on Earth. There are also igneous rocks in the park that show lava flows from the sea floor around 750 million years ago. Like we mentioned, there was a thrust fault that was created in the area. This is visible in the park, the Lewis Overthrust Fault, where the rocks on top are over 1 billion years older than the rocks below them. It is believed that the movement of these plates occurred at a rate of less than ½ an inch per year, which seems obviously really slow, but honestly, I thought that was kind of fast for geologic time. Plates moving on top of each other? ½ an inch a year? That's not that bad. These intense geologic events also created folding, which is known as anticlines and synclines. Of course, by the name of the park, you can assume that glaciers played an important part in shaping the landscape. Around 2 million years ago, the Earth cooled and caused giant ice sheets to form. From this time until around 12,000 years ago, when the glaciers began to melt, these ice sheets repeatedly advanced and retreated, causing erosion of the landscape. Glacial features such as lakes, moraines, and large valleys can be seen all around the area. The Earth is now warmer again, so we don't see glaciers of this scale anymore, but smaller ice sheets still remain. Next, we have Makashika State Park. Makashika State Park is the largest state park in Montana, and it has a badlands topography and is known for incredible dinosaur fossils. Makashika is a Lakota name, which translates to bad land. Badlands topography is created by erosion of weakly cemented together rocks through rainwater. Erosion of these rocks cause fossils that were within them to be unearthed. This park also shows the end of the Cretaceous period boundary that we talked about, that shows the mass extinction in the rock record. Next, we have the Rim Rocks, which are a sandstone feature near Billings, Montana, that was deposited during the time of the Western Interior Seaway. Due to regional uplift, the Yellowstone River changed directions and began cutting through these sandstone rocks, creating the cliffs and interesting formations that are seen today. There are many interesting geologic formations and rocks in the state that are studied and used for geologic research. One being the Stillwater Complex, which is a large, layered, mafic igneous intrusion that intruded into 2.7 billion year old rock. This formation is one of the world's oldest layered intrusions and contains the world's highest grade platinum group element deposit, which makes it extremely geologically significant. This formation not only produces platinum, but other metals such as palladium, gold, silver, copper, and nickel. And lastly, there is Bug Creek, which is another location where this Cretaceous tertiary boundary can be seen in the rock record, and it also has an abundance of dinosaur fossils. So that's all I have for you today about the geologic history and minerals of Montana. I hope you enjoyed the video and maybe learned something new. I'm glad you guys are really seeming to enjoy this new series because I love making these videos. I love having an excuse to research the geology of different topics. Be sure to comment down below which state or region or country you'd like to see me talk about next. Anyone who's already suggested, I've already written down your suggestions, so I will be getting to them. Or if you have any other unrelated to the series videos you'd like to see me make, let me know, because I would still like to do crystal chat videos, but people seem to like these more. So whatever you guys want me to make, I'll make it. Don't forget I have a crystal shop, Cosmic Geology, which will be linked down below, as well as my second channel. I don't post on there very much, but I'd kind of like to start making baking videos or shorts or something. I don't have that much time to be starting new projects, but I would like to just post some stuff on there. I've been making baking videos on TikTok, and it's fun because I like baking. And my birthday's coming up, so I'm going to be baking myself a birthday cake, so maybe I'll make a video about it. And again, I haven't gotten any new crystal inventory in my shop in a long time. I'm not thrilled about it, but I do have tons of other things. I make wire-wrapped jewelry, crystal bracelets, rings, paintings, crystal paintings, notebooks. I have lots and lots of stuff, so I'd love it if you check it out. Thank you so much if you check out my shop. I appreciate you. Thank you. You can use code YouTube for a discount on any order at any time. Thank you so much for watching. Please like the video if you liked the video. Subscribe for more geology and crystal content, and I hope you have a great rest of your day.